Hi, in this video, content related to sensor failures and troubleshooting will be shared. UAVs are equipped with various sensors such as GPS, IMU, barometer, compass, optical flow sensors, vision sensors, and cameras. These sensors perform critical tasks such as determining the vehicle's position, orientation, and perceiving the environment it flies in. However, over time or due to external factors, these sensors may fail. Sensor failures are usually caused by crashes, hard landings, or improper handling. Knowing the symptoms of sensor failures and how to troubleshoot them helps. UAV users identify potential issues and enhance flight safety. This video will provide detailed information on the symptoms of the failures in different types of sensors and how to address these issues. Common sensor failures in UAVs include signal interference or weak connections, poor or incorrect calibration, software incompatibility, weak or lost data transmission, sensor errors due to weather conditions, incorrect data readings, incorrect measurements due to temperature change, sensor interferences, insufficient power supply, or voltage fluctuations. Sensor non-responsiveness during the rapid movement and failure of the sensor warning system to active in case of malfunction. In GPS failures, which provide position data for UAVs, symptoms such as inability to maintain position, erratic movements, or failure to return home correctly may occur. In this case, the GPS signal strength should be checked, antenna connection verified, and firmware updated. Additionally, it is recommended to conduct flights in open areas as much as possible. In IMU failures, which ensure stable flights for UAVs, symptoms such as unstable flight, drifting, frequent altitude change, and sudden tilt may be observed. In this case, recalibrating or IMU, checking for vibration issues, and verifying the IMU's temperature are necessary. In barometer failures, which provide altitude data for UAVs, inconsistent altitude measurements and sudden altitude change are observed. Cleaning the barometer, checking the airflow affecting the barometer, and recalibrating under stable weather conditions can resolve the issue. In compass failures, which provide orientation data for UAVs, symptoms such as spinning during hover, incorrect heading information, or failure of the return to home function may occur. In this case, recalibrating the compass, avoiding the magnetic or electromagnetic interferences, and checking for presence of metal objects in the environment are important. To effectively resolve various sensor and camera failures, it is essential to understand the functions and characteristics of the sensors. In optical flow sensor failures, symptoms such as poor position holding in GPS denied modes and drifting during indoor flights may be observed. In this case, cleaning the sensor lens, ensuring sufficient ground texture, and providing good lighting are necessary. Additionally, it is important to remember that signals reflected from smooth surface like glass or water can affect the sensors. Vision sensor issues may manifest as failure to detect obstacle, incorrect obstacle detection, and unwanted avoidance behaviors. In such cases, cleaning the sensor lenses, checking the physical damage, and verifying sensor calibration are necessary. Testing under different lighting conditions can also be beneficial. In infrared sensor failures, symptoms such as increased risk of collision with obstacles, incorrect altitude readings at low altitudes, inability to hover stability, and difficulty in safe landing may be observed. These issues may be caused by environmental temperature change or sensor alignment errors. Therefore, checking sensor alignment and environmental conditions is necessary. Additionally, the prime cause of sensor failures is either sensor malfunction or broken cables connection to the sensor to the flight control board. Replacing the sensor or repairing or replacing the broken cable can resolve the issue. Camera failures may manifest as blurry or distorted images, color abnormalities, and recording or streaming errors. In this case, cleaning the camera lens, checking gimbal functionality, verifying memory card compatibility, and updating the camera firmware when necessary. The gimbal, which the camera is attached to and keeps the camera stable during flight, can also fail on its own. In this case, the camera will not stay in the desired position or the image will be distorted. For UAV technicians and operators, the correct use of sensor diagnostics tools, and software platforms is crucial. Multimeters for voltage test and oscilloscopes for signal inspection are indispensable tools in the diagnostic process. As for software platforms, DJI Assistant 2 for DJI drones, Autopilot Mission Planner for custom drones, and PX4 Q-Ground Control for PX4 based drones should be preferred. Additionally, checking flight logs to observe sensor errors or inconsistencies after flight is necessary for early detection of potential issues. Flight controller acts as the central nervous system managing navigation, stabilization, and autonomous flight capabilities using advanced firmware. Battery management systems use complex firmware algorithms to monitor battery health, optimize charge cycles, and provide critical power-related information, ultimately enhancing the drone's lifespan and flight safety. When encountering a drone sensor failure, troubleshooting flow cards can be used. First, when a sensor failure is detected, check if the sensor is receiving power. If it is receiving power, proceed to next step. If not, check the power source and connections. Then evaluate whether the sensor is properly calibrated. If the calibration is correct, proceed to next step. If not, recalibrate the sensor. In the third step, check for any external interferences such as magnetic effects or adverse weather conditions. If there is an interference, apply solutions such as relocating the sensor or reducing the obstacles. If there is no interferences, check if the sensor firmware is up to date. If it is not up to date, update the firmware. In the fifth step, check if the wiring is intact. If there are loose connections, repair or reconnect the cables. If the wiring is intact, inspect the sensor for physical damage. If there is a physical damage, replace the sensor. If there is no damage, check the compatibility between the controller and the sensor. Finally, test and verify the sensor's performance. If the issue persists, it is recommended to contact the UAV manufacturer's technical support unit. In this section, we covered UAV sensor failures and troubleshooting. I hope the contents have been helpful. See you in the next content. Goodbye.